Hi, sweetheart. Hi, this is my... I don't know who this is. Hi, this is Miss Litton, and this is my wonderful 7th period class of honors biologists. Say hi. Hi. Here come Deb. Okay, so we have a quick review today. Chapter 2. Let's break it down to the key things that we need to know. Okay? Key thing number 1. You need to know the parts of an atom. So very quickly, the atom story. Here we go. Ready? The atom story. Atoms are made of protons, neutrons, and electrons. The protons and neutrons are in the nucleus. Atomic mass. The electrons are in energy levels. 2, 8, 8 to 32. 8, 8, 8 is great. Octave rule. Yay. Okay, so parts of an atom. So I should be able to give you any element, and if you look at it, you go, oh, this is the what? Atomic
mass number.
What is this number I circled right here? Atomic number. Atomic number. And the atomic number is equal to number of protons. What's this number right here?
Atomic mass.
Mass. And what is the mass equal to?
Number of protons.
Protons.
And neutrons.
Remember what we just did? The protons and the neutrons are in the nucleus. Atomic mass. Remember that part of our song?
Yep.
Okay. Is everybody in their group share notes? Because you look distracted to me.
No, we're not.
You're not?
We are.
What's going on?
It's slow. We got here.
I'm sorry. See, do you see how she owned that? That makes me love her. Okay? Because she didn't go, nah, nah, nah. It's just, I got here late. Thank you. All right. So, atomic number, atomic mass. So if I wanted to solve for the number of protons, I just look at the little number, right? And I know my number of protons equals
3.
And I know however many positive charges I have, I must have the same number of
negative charges.
So electrons equal 3.
3.
And then the number of neutrons would be, I take the protons and neutrons, subtract off the protons, and I'm left with neutrons. So neutrons equals what? 4. Good. Now, if I want to put the electrons away, how many electrons can I put in the first energy level? 2. So if I'm dealing with these electrons right here, I put 2 in the first level and then 1, right? Because 2 plus 1 together then would be 3. Now, is lithium a happy element?
No.
No, because there's 2 ways to make an element happy. 2.
Fill the outer shell.
Outer shell, the valence shell, get it to 8.
8.
So anytime that molecules are interacting or atoms are interacting with other atoms, it's to do that, to gain stability, right? And that explains our different bonding. So we did structure of an atom, and then we looked at things like, hey, look at this periodic table. When we look at the periodic table, if we're looking at the vertical, we're looking at what? Those are groups. And horizontal, we're looking at what? Periods. Okay? When we look at the groups, here's group 1, here's group 2, here's group 3. What does group 3 have in common?
Group 3, they all have 3 valence electrons.
They all have 3 valence electrons. Group 2 has
2
valence electrons. Group 7 has 7 valence electrons. And we know that atoms interact with other atoms based on the number of valence electrons. That determines their behavior. Because remember, they're always trying to get
happy.
Just say it. We don't need to drag it out. Neutrons. Say it.
Happy.
Happy. Okay. Now, if we are looking at periods, we know all of them are in the same energy level. Right? So hydrogen and helium are both in the same energy level. Hydrogen has 1 electron in that energy level, and helium has 2. Okay? When we look at this whole period right here, they're all working out of the second energy level. So this is 2, 1, 2, 2, 2, 3, and so on until we get to 2, 8. Okay, so we can see that when we look at periods, same energy level. When we look at groups, same number of valence electrons. Okay? Then we talked about variations. When we look at an atom, if I vary the number of electrons, what's that going to be called?
An
ion.
Oh, no, that's
If I vary the number of neutrons, vary neutrons, what's that going to be equal to?
Isotopes.
Are you guys looking for your labs?
Yeah.
They're right there on the table.
Nice job, gosh.
What did you tell me this was?
Isotopes.
Isotopes. When you vary the number of neutrons. Now, when you vary the number of electrons, if you gain or lose an electron, you're going to have a charge on yourself, right? And what do we know about opposites?
They attract.
And the same repel,
Oh.
right? When we vary the number of neutrons, what are we going to change? The atomic
Mass.
The way it reacts with other elements is still going to be the same because it's the number of electrons that determine how you react, right?
Mhm.
But I can detect it, and that's why it can be used in PET scans and things like that, because its mass is different. And we talked a little bit about that as well. Okay, I am moving on. Next thing I want to talk to you about are the different kinds of bonds. We talked about covalent bonds. Covalent bonds are when you share. Now, there's ways to share. What were the two kinds of sharing?
Non-polar
Non-polar
and
and
polar.
polar.
What's polar?
Which one do you share equal?
Non-polar.
Non-polar. So there's no pull. Nobody has a greater pull on the electrons than another. Polar, though, you share
Unequally.
unequally. Okay, unequally. And so as a result of a polar bond, you could have areas if one element is hanging on to the electrons, if they're not here, if they're closer to this guy, if the electrons were closer to him, he could end up being partially what? Negative if they're closer to him,
More electrons.
partially negative, and this guy would end up being partially positive. And the thing you know is any molecule or element that is an ion, any molecule that has a charge, any molecule that's polar, so it has partial positives and partial negatives, that will dissolve well in water, and that's called being hydrophilic. Yeah. But if you share exactly fair, if you're non-polar molecule and there's no charges on you, then you will be
Phobic.
Phobic.
I'm sorry.
Yeah, hydrophobic.
I'm sorry.
Okay? All right? Now, if you have an ion, if you've got a positive ion and a negative ion, as soon as you're dealing with ions, that's going to be hydrophilic. Okay? And they dissolve well in water. All right? So we talked about covalent bonds, ionic bonds, and then we started talking about hydrogen bonds. And we said because water is a polar molecule, because that doesn't show up, because you have hydrogen, and oxygen, and because oxygen hangs on to the electrons a lot tighter, then oxygen is partially negative and the hydrogens are partially positive. So you take one partial negative, it will be attracted to another one's partial positive. So it's two totally different water molecules attracted to each other. That's a hydrogen bond. But if I look within a water molecule, if I'm oxygen and my hands are hydrogen, right? I'm oxygen, this is what kind of bond is this? Polar covalent, okay? Is there any hydrogen bonding in a single water molecule? No. There's only hydrogen bonding. If we are all water molecules in this room, we would arrange ourselves like this, right? Because my partial negative would be attracted to his partial positive, and there'd be this little weak bond right here called an H bond. Okay? And it's those hydrogen bonds that give water all of its properties we were looking at, like high heat capacity, because all of these hydrogen bonds can hold a lot of energy right here. So high heat capacity. And these hydrogen bonds, it takes a lot of energy until we evaporate. Okay? High heat of vaporization. These hydrogen bonds allow water to be a good solvent because water molecules can arrange themselves around anything that's ionic or charged, polar, because the water can arrange itself around there and work its way around it because it's got partial positives and negatives. Who doesn't water mix well with? Oil, because oil is hydrophobic because all of its long carbon fatty acid chains are all shared equally usually. If they're all shared equally, they're non-polar and water can't interact with it.
Unless it's a plant-based.
Yeah. We talked about adhesion and cohesion. Okay? Adhesion would be a water molecule to a different substance. Okay, water molecule to a different substance. Cohesion would be water molecule to water molecule. So if I dip my hands in water and I went like this, and I could see like the water between my fingers, right there between my fingers, that would be due to what?
Adhesion.
Which part would be adhesion?
Connecting to your
Water to the skin would be adhesion, but water to water would be what?
Cohesion.
Cohesion. I'd say that's a factor of cohesion. That's why it could do that. Because, of course, this is going to be moist if I get it wet, but the very fact that there's water in the space between them, that's due to cohesion, right? Cohesion.
Cohesion.
Okay? Adhesion would be like the meniscus where it climbs up the side.
Mm-hmm.
It's adhering to the glass of the graduated cylinder.
Adhesion is just not.
Okay.
too
If I jump and land in a pool, smack. Okay? That's due to the surface tension that's caused by what? Cohesion. Water to water. All right? Okay. So we talked about surface tension, and then last but not least, we said, so this is a great biological Benny to have because ice is less dense. Solid is less dense, so it floats on liquid water, and it makes an insulating layer and protects all the life below. If ice was more dense, it'd sink to the bottom, and all lakes would freeze from the bottom up solid, and everything in it would die. Okay? So those were our properties of water. Then we talked about how am I doing? We're doing great. Okay.
Good time. You got this.
All right. I have to be done at 2:58 because I have hair. So if we look here and we look at pH, priorities, it's very expensive. So when we look at the pH, we want to remember that pH is a measure of the number of what? Hydrogen ions. Okay? And if you are acidic, you have high
hydrogen
ions, okay? If you're basic, you have
low hydrogen ions.
And every change, if you jump, you say, I'm on 6, you're on 5. I'm on 6, you're on 5. What's the difference in hydrogen ion concentration?
10 times.
10. So between the two of us, there's 10. But now if you're on 3, between the two of them, it's 10, but between the two of us, it's 10 times 10 is 100. And now it's 1,000. And now it's 10,000. Okay, so those are big jumps. Okay, what keeps our pH normal in our cells? Buffers. Okay, that brings us to organic molecules. Okay, now for organic molecules, I'm skipping to here. Here. Where am I skipping? Here. Here. No, not there. Here.
Oh, thank you. Let's take this picture real quick.
I've already Instagrammed it.
Okay, then let's.
Okay, I'm just saying.
Well, I mean, what if I can take a better picture? I mean.
Okay, so now I want to start just with carbs. Okay, so you know I'm talking about carbs. Okay, so for carbohydrates, right, the base unit for all carbohydrates are glucose. If I have a single glucose, I have a mono what? Saccharide, monosaccharide. Okay, the most common monosaccharides are glucose, fructose, and galactose. When you put two glucose molecules together, you have a disaccharide, and that's called maltose. A glucose with a fructose. What is fructose, by the way? A what kind of sugar? Fruit sugar.
Fruit sugar.
Glucose and fructose make sucrose, which I would find on my table. Table sugar. And glucose plus galactose makes milk sugar, lactose. We all right?
Yep.
Monosaccharides and disaccharides are very quick energy. Okay? Now, if I make large polymers, they will fall into two categories. They will either be all about structure or they'll be about energy storage, which I can snap off into little energy units if I want to. Now, you and I store energy different than plants. Plants make polysaccharides, large complex carbohydrates, and they store it as what? Starts with an S, and it's on the board. Starch. That's how plants store their carbohydrates. Starch. Think about a baked potato. Starch, right? Corn on the cob, inside the kernel, starch. That's all starch. Okay? You and I store our carbohydrates. We can only store about a 3 to 4 hour supply. We store it in our liver as glycogen. That's why we want to eat every 3 to 4 hours. Okay? So these two right here are about energy storage. These two are about structure. Plants can build their cell walls out of carbohydrates, and it's called cellulose. Fungi can build their cell walls out of carbohydrates, and it's called chitin. And also in exoskeletons. Now, if I want to hook two glucose molecules together, what's the name of the reaction? Dehydration synthesis. And one glucose molecule is stable all by itself, and another glucose molecule is stable all by itself. But when I hook them, how am I going to get them to come together if they're already stable? I have to do what from them? I got to take something from them. So for one, I'll take away a hydrogen. The other one I'll take a oxygen and hydrogen. HOH is?
H2O.
H2O water, and then I can hook them together.
Yeah.
They will find fulfillment in themselves. If I want to break them apart, for instance, when I store glycogen in my liver, I will slowly snap off some glucose molecules out of my liver to release it into my bloodstream, and that is going to be called hydrolysis. Hydro meaning water, lysis to break. Perfect. Okay, so that's important organic molecule number one. Let's do number two, lipids. Lipids is not a convenient, here's the brick and here's what it builds. Okay, we have several different kinds of lipids, but we can break them down into two. One is straight up fats. Fats have glycerol with 3 long fatty acid chains, 16 to 18 carbons on, right? Okay. So those fatty acid chains can be saturated or unsaturated. What kind of fats do plants have? Saturated or unsaturated?
Unsaturated.
Unsaturated, which means they're not saturated with hydrogens. So they have double bonds, which puts kinks in their chains, which makes them a
liquid at room temperature.
And healthier for us, right?
Very much.
But animals have saturated fat. So what would this one represent right here? Saturated fat. Why? Because all the chains are straight.
No kinks.
Can form a solid and can form at room temperature. Could be a solid in my arteries, right? Okay. The second big category are steroids. This is the shape of a steroid. Now I'm telling you, on the quiz, I will have diagrams that look like this, and I'll say, what important molecule will this build? Or what monomer is this? Glucose. I will have pictures that look like this, 4 rings together like that. And you need to be able to recognize that's a steroid. Okay? I can have long fatty acid chains and a glycerol, and you need to go, ooh, that's a fat. Okay? Yes. You need to be able to recognize these shapes. I told you in class, right? That's why we had images, and I'm telling you now. Okay? Then when we look at some examples, fats and oils, we use that for energy, long-term energy storage, and heat and cushioning, a little something, something. Okay, phospholipids are in cell membranes. If you remember, a phospholipid, I said we took away one of those chains and put a phosphate group, but those make up our cell membranes. Steroids are hormones, cholesterol are examples of steroids, and waxes like in your ear, fur, plants for waterproofing. Okay, important organic molecule number 2. Important organic molecule number 3 are proteins.
Amino acids.
Yes, and they are built out of amino acids. And how many different amino acids do we have? 20. And the reason is they have this all in the same amino, hydrogen, carboxyl group. The part that changes this, there are 20 different R groups. Some of them have charges, some of them don't have charges on them. So, but there's 20 different amino acids. You hook those together, and you can build things like muscles and messengers and antibodies and enzymes and hair and nails. When you do dehydration synthesis between 2 amino acids, it's got a special name. It's called a peptide bond. Very peppy. Oh, peptide. Okay? Think about proteins could give you energy or something. Or a protein, you got to have muscles to be a cheerleader and be peppy. Pep rally, you got to have muscles. That was a really good chair move right there.
Yes.
Okay, peptide bond. All right. And your 4th important organic molecule are nucleic acids. And those are built out of nucleotides. Nucleotides always have a nitrogenous base, a sugar, and a phosphate. Now what's different is there are 4 bases you find in DNA, and you learned this last year: adenine, thymine, guanine, and cytosine. So those are the 4 bases you find in DNA. There are 4 bases you could find in RNA, and they're the same 4, except not say no to what one? Which one do we say no to? No
It has
thymine,
it has
and
uracil.
instead you have
Uracil.
Okay. The sugar will differ between DNA and RNA. The sugar in DNA is deoxyribose. The sugar in RNA, I'm super tired. The sugar in RNA is ribose. Then the phosphate part is the same. There's something else that's different too. DNA is our genetic code book. It tells us, gives us the information to code for all of our proteins, bless you. Whereas RNA helps us actually build our proteins. DNA is the code book, RNA helps us build our proteins. Another thing is DNA consists of 2 chains, RNA is 1 chain. Good. All right, and so we have DNA is our genetic code, RNA is protein synthesis. ATP is another kind of nucleic acid. It goes adenine, ribose, phosphate, phosphate, phosphate. It's like 2 bonus phosphates on top of it. Okay? So that is that, and your time for your present. Here's your present. It's got a bow on top of it. Now, I'm going to tell you ahead of time, I'm asking 7 questions on your quiz tomorrow. 7 times 2 equals how many points?
14.
It's a disappearing present. But your present is... That is my present to you.
Oh, you're the
Why?
best.
Because I love you.
And we love you too.
And we'll do another quick review at the start for 0 period, and then you have your POGL, and then your quiz your last 10 minutes. The rest of you will finish wherever we are in the notes, and then your POGL, and then your quiz the last 10 minutes. Yes?
Is it with your bio buddy or
It can be anyone in your class.
What if you
Can't be like with my mom, who's a biochemist. Yes?
That would be
Whatever we're taking notes on during class, will that be on the quiz?
Yes.
Just pay attention. Not for 0, we already finished.
You're finished. Yeah, you're done.
We're
we
so cool.
got it done.
Even
Okay.
though they have
Anything
16
else?
in a row and we don't.
Yes. Okay. Great. Love you greatly. Be smart. Study.
Do you have matching Fitbit?